Now we're doing the pre-lab. This is mine, not yours. Don't take this one out of the room, please. Here's your correction slip. You get to keep that. Don't forget, your correction slip has every bit of information that I'm going to grade and how many points it's worth. Ladies and gentlemen, please don't forget to update your table of contents with this, your third lab, which is called the isotopic pennies of coinium. You can call it the penny lab, you can call it coinium. That will be your title. How many points will you get for writing down your title? One. Let's look together at your purposes. Looks like I took one off because how many do I see? I see 6 here, but how many did I say it was worth? 7. So maybe I'll just give you a free point. So this is the one time I say write them down exactly as you see them. And these are little, do you agree? Now a little bit different on this, there is a section called background, which is a brief description of what you're going to do. Do you see this section called introduction? Your background can be figured out. You can come up with the background by reading those 2 very small paragraphs. Pennies that were made before 1982, I call those pre-82, were made of almost all copper. And they weigh in the vicinity, very approximate, right around 3 grams. Pennies made after 1982 are made of mostly zinc. And they weigh, and this is very approximate, about 2.5 grams. So if I put a penny on a balance, I can tell if it's pre or post 1982 by its mass. Do you agree? You are going to be given a sealed canister that has a known amount. I'll tell you if you maybe have 11 or 12 or 10 total pennies. And you're going to have to tell me without opening it how many are old and how many are new. Is that clear? So you're going to have to tell me the percent abundance, just like what we've been working on. You're going to have to tell me your percent abundance of old and new pennies. Does that make sense? If you read that second paragraph, each canister is going to be given each group will be given a canister containing a mixture of pre and post 82 pennies. I will provide the mass of the empty canister, and I will provide the total number of pennies in your canister. And then you have to come up with a way to do this. Okay? Let's look together at your, so you have to do brief description, 3 sentences max. Make a note to yourself, don't write me more than 3 sentences. And that's like adding that's adding 1 extra sentence, 1 more sentence than I think you'll need. So what do I think you should be able to do? 2 sentences. If you're very verbose, is that the right word? If you're very verbose, you can go ahead and use 3. So your objectives, you're going to apply correct mathematical manipulations to our sample to find relative and percent abundance. We're going to use our 2 different masses of pennies in a container that's sealed as a model for isotopes. Do bunch math. We're going to use sig figs. Collect data using laboratory equipment correctly. The only thing you need is a balance. And we're going to make sure that you know the difference between data and calculations. Let's look at the pre-lab together, please. There are 5 questions. Do you agree? I'm telling you, show all work for credit. My motto is, what does this say? No work, no credit, no exceptions. What else do I say? No units, no credit, no naked numbers, show your work. If you pick up your calculator and do magic math and don't write it down, and I don't know what you put into your calculator, then I don't give you credit for it. Does that make sense? Okay, question 1 is the average atomic mass of magnesium. Look carefully at those values. Do you see that I give you the isotope notation for magnesium 24 and then the more accurate AMU mass, 23.985, you are going to use the 23.985 times 0.7870. Please notice on this problem that I already gave you relative abundance. I already took it out of percent. Are you clear in what I just said? So you're going to do mass times abundance plus mass times abundance plus mass times abundance, add them up. Do you agree that your answer is going to be between 24 and 26 AMUs? Okay. 2 is another easy one. You've got everything there. This time you're just using the 85 and the 87 as your masses. 3 is titanium, and I feel like I already gave, no, I did zinc. That's a 5, so that's easy. Show your work, write them down. 4 is the only one that's hard. So 4 we're going to work on together in just a moment. And the definitions, guys, I'm going to take more points off every time. Your definitions, you need to include your terms. So you're going to write down isotope. Can you see me on there? Yep. Isotope, and then define. Then start a new line and put relative abundance. And then define. Because then it's quick for me to go through and read each one. Is that clear? Okay, don't run them all on in one line. And especially don't run them all on in one line when you don't even put the words in, because I don't know where one starts and one begins. Let's go back to question 4. Element X has 2 isotopes, 100 and 104. So folks, I'm going to do this. I'm going to put 100 and I put 104. And what did I tell you my average mass was? 101? I'm looking at this problem and doggone it, there's nothing there that's helping me. But there's only 2 isotopes, so I know that my total has to be 1. Do you agree with that? This is what you're doing in your lab, so pay close attention. I know that my total has to be 1. So it doesn't really matter, I'm going to pick this one. If I call this one X, what does this value have to be?
100 minus X.
Louder?
100 minus X.
1 minus X. This is what you're doing in your lab. Solve it, please. Go. Let's race. And what you're getting now is going to be your relative abundance, which we will turn into our percent. I have one word for you. PEMDAS. PEMDAS this. I'm enjoying my coffee while they're calculating the answer to Prelab question 4. What? 75%. 75%? So are you getting 75% for X?
For X.
Okay. Which means that this one has to be who's looking askance at this because they have no idea how we got that. Okay, so you're going to have to distribute this. I'm just going to write this as 100x plus 104 minus 104x equals 101. Do you agree with that? So when I combine my x's, do you agree I get a negative 4x right here? And I get negative 3 right here? Are you all good with what had just happened? Does everybody know how I did that?
Yeah.
Okay, so when I solve for x, I get 3/4. But fractions, here's us in fractions. No fractions. We hate them. So it's 75%. And I could probably go 3 sig figs on this one, correct? But 75% will be good. Now this is what you're going to do. You're going to do this in your lab.
You could actually only go to one significant figure.
Did I give you 100 or 100 point?
100.
But now remember, if I'm doing isotopes, those are exact numbers.
Sure.
So in theory, I gave you exact numbers for all of these. Except this one isn't. That's the only one that we would do. Because that's our weighted average. So, really, we probably want to go to 3 sig figs on this. But you could argue that you could go to infinity sig figs as well. And since you come up with exactly 0.75, 0000, I wouldn't be too hard on it. Does that one make sense to you? Good. Yes.
So you would cut this off if you would like.
Not on this one. On these where it gets a little harder to figure them out, I will frequently on an assessment say report your answer to 2 decimal places. Okay? So there is your pre-lab, not hard at all. Now when you show up, you have to have a data table. And look with me, please, at the procedure and data. It says record the number of the canister in the data section. That sounds like a piece of data. Do you agree? The information will be on your canister. The mass of the empty canister and the number of pennies in your canister will be provided. Record those values in your data section. Determine the mass of your canister. Record the mass in the data section. I have a bunch of loose pre-pennies and loose post-pennies. You and your lab partner or partners are going to figure out a way to come up with the average mass of old pennies and the average mass of new pennies. You're going to figure out how to do this. And you're going to include in your data table space to put the data that you're going to collect to do that. Does that make sense to you? The data have to be recorded in the data table. Record your data in a ruled, clearly labeled data table. Include appropriate units with data. You will design your own data table. Your instructor, moi, will not design your data table for you. If you look back on your procedure, I wrote the words record like all over the place. Every time you have to do data, I wrote record. So if you read your procedure, it'll tell you the data you need to collect. Is that clear? You need to design a data table and show up with the data. It's not very big. If you count how many pieces of data I told you to record, I think you can't be more than 5 or 6. So you're going to do this, and that's what you're going to have. So when you show up to class, I will expect your title, your purpose/objectives, 2 to 3 sentences for your background, very well documented, all work shown, pre-lab questions, and a data table. If you look at your data correction slip, there's another one that tells you, like I'm going to give you a point for your canister number, a point for number of pennies, a point for, what are those 2 letters? Where it says mass of something container. What are those 2 letters?
MT.
Say it faster.
MT.
Empty. MT means
Empty.
empty. Got it? Empty is empty. Your data for the average mass of pre-82 and your data for your mass of your post-82 and the mass of your container in pennies. So really, there's no big secret here. Come up with your own table. Have you got it?
Got it.
Okay, stop please.